Hello everyone and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to talk about making file system images. So again, an overview of our high-level process. We started out with a call. Someone called us. We said yes, there was an incident. We did some live analysis and we decided to do some dead analysis, and now it's time to acquire an image or images and then proceed to do some dead analysis. And this is where the majority of forensic tools out there live, in this block here. If you're going to take an image, the first thing you have to decide is what format will that image be. There are a couple of different choices for image file formats. The easiest one is RAW. RAW is just nothing but all of the bytes from the file system compacted together in one big block. So a RAW image will be exactly the same size as the media. So some tools can operate on compressed images and some of them will not operate on a compressed image. Even if your tool will operate on a compressed image, it's going to be a lot slower because it has to uncompress the image all the time. There are also several proprietary formats, some of which embed the metadata into the file. So there's one big happy file, and essentially what they have is chunks of raw data with metadata shoved in every so often. That's another popular file format. You also have proprietary formats with the metadata in a separate file. So essentially what you have is a raw file and then metadata in a separate file. You can also create a raw image and then create hashes to store in a separate file. Now, a little bit about hashes. You should always be hashing these images. Now, we always will make an overall hash of the image. It's good to hash the subchunks of your image as well. Why would you want to do that? Well, there are a couple of reasons. If you have media that is potentially damaged, if one bit gets flipped on that entire 3 terabyte drive, the hash will come up different. You do not want to have to throw away an entire image file because of a bit flip. That's one reason. The other reason is if you recalculate the hashes as you go to verify that you haven't changed an image, it's helpful not to have to do that on the entire image. So we'll show you some tools that will do this for you. Now, there are different ideas on what format is best. There are people that like EnCase, which is a commercial tool for doing forensics. And they will tell you that expert witness format is the best format that you can use. I would disagree with that. I think that the raw format with a separate file full of your hashes is probably the best because every tool in the world will read a raw format file. Now, some of the proprietary tools will make that difficult for you, but it's still possible. So I like compatibility. So I like the raw format. So how do you create a raw format image? It's very simple to do. There is an ancient Unix utility called dd, which really just moves bits around. And on your Linux system, if you say dd and then you give it if equals and the name of your subject device, let's say it's /dev/sdb, and of equals the name of your image file, which might be your case number .img or this drive identifier, etc. And you can give it a block size. Normally, block size of 512 is good. You can improve performance by giving it a larger block size, but if you give it a larger block size than 512, you might have issues at the very last chunk because you need to use a block size that's evenly divisible into the size of your media. 512 bytes is the standard by far for sector sizes. There are a few file systems out there and a few drives out there that might have larger blocks than 512 bytes, but they're all multiples of 512. So this is the safest option. Some years back, a few folks got together and they wrote an enhanced version of DD just for forensic stuff. That product is called DCFLDD, which should already be installed on your system if you ran the script that I presented in an earlier video. And it adds to the standard DD hashing. So you can tell it hash equals, and then you can pick an algorithm. Now the default is MD5, which I don't personally recommend. I recommend something like SHA-256. It's fast enough, and it's better than MD5. Then you can also set a hash window. Maybe you want to hash every megabyte or every 10 megabytes. It's up to you. Don't set this ridiculously low or you're going to have a huge hash file and it will take forever to make your image. You can also set a hash log and set that value equal to the name of the file that you want to create. If you don't set a file, it will send all of this information to standard error instead, and you need to capture it into a file. So if you're going to do this, you should probably be write blocking. Now there are commercial hardware write blockers available out there. Typically they work with only one kind of drive, although SATA is pretty much the standard today. They are out there for $350 or more, so they're not cheap. You can also use the USB write blocker as described in the USB forensics class here at Pentester Academy. The nice thing about these, they're cheap. They cost you about $25, but they're very slow. The microcontroller that I used to develop those is limited to full speed or 12 megabits per second only. And it's great for thumb drives, but if you have a 3 terabyte hard drive, you probably want something else. What could that something else be? Well, on the software write blocking side, you have a couple of different choices. You could use UDEV rules, also as described in the USB forensics course, or you could boot a live forensics Linux on the subject computer, something like SIFT or similar. Or you could boot the live forensics Linux on your forensics workstation and then mount the drive. I don't really recommend this method, and I don't really recommend booting the live forensics on the subject computer either, unless there's no good way around it. Sometimes you might have something like a laptop where the hard drive is not easily accessible. So you might decide that this is a better option. But in most cases, I think you're best off to pull the drive and image it directly. And we will talk about that in a future video. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon.